So if you guys want to grab a seat, we'll get started here. Our next speaker is Huntsville's own, well, actually Birmingham.
It's both.
Both. you live in Birmingham, but you do a lot of work up there in Huntsville, right?
Yep.
Yep. So Joe's a local guy. I've known Joe forever in the pen test community. He's a heavy red teamer. Works on for a lot of interesting customers. We'll just say that. And now he's doing a lot of consulting on your own. Now you started your own business, right?
I did.
Right. So, but he's going to come here and talk to us now about web shells as a covert channel. Joe's got some good stuff to share. He's got the business I've been in with Joe. He is well known for web hacking. So it's going to be some good stuff.
Okay, everyone, how's it going? First, I want to say this is my first BSides. I've always had other things going on, so this is pretty cool to have something here in Huntsville. We don't always get lots of things, so I always encourage everyone to support what we do get in our local area. So continue to come to these things, and maybe we can pick these up and make them even bigger. So I want to talk about some web shell work. So first of all, who am I? My name is Joe Vest, co-founder of a security company called Menace. We actually just made it our year mark, so that's been a crazy year to get through that. Been doing IT and InfoSec for over 17 years, mainly focusing on offensive security, red teaming type work, pen testing, so not as much on the defense, but more on the attack side. And I've got some letters behind my name, like you guys probably have as well. So web shell, first of all, I'll just start. Has anyone used them on any kind of test or anything? Familiar with these things at all? Okay. So let's get into it. What is the web shell? Really all it is server-side code that you're going to put and execute on a web server. It's honestly no different than what you'd put on that would display a web page. So your home corporate page, it's a .aspx page or .php or JSP or whatever it is that renders HTML. The only difference in a web shell is the intent behind it to issue commands for remote control access from someone that should not be doing that. So that's the fundamental of what I have with a web shell. These things have been around for a long time. And why do you use them? Well, I spend a lot of time on the web side of things. And whenever you're doing a thing, so the theme of this, I have a tool, I'm going to show some things, but the theme is really more of a mindset and understanding of how to approach being an adversary, which on the other side is how adversaries think, so you understand how to better defend. So web applications are still valuable. Right now, security, even though it's still not great, it's still gotten better, and there's not a lot of remote exploits. Exploitation into networks, commonly through client-side. Client-side browser flaws, phishing, some social engineering type piece. So that's how you get in. But web applications are still a way to get remote access into a network. People are really surprised at what you can do through a web application and gain access. Now, I'm not going to talk about web app hacking directly, just the payload side, but feel free to throw things, ask questions, whatever you want. I'm just here to give you some info, so if you want other things we can talk about, we can definitely go through that. The other thing I like about web shells is they're great for long-term backdoors. With a web shell, you have normally, so let's say I'll use Meterpreter. Maybe that's your payload you want to use. It's so common. Definitely not my favorite for doing more advanced red team things, but that's a different story. But it's a great tool that has things, but it's a client side that makes a connection outbound. So it's always having a connection. Versus a web shell, it's only on demand. So it can be very, very quiet and only used when you need it. And so how to use it? First thing, you've got to have control over a web server. Like I said, I'm not going to go through how to get that control, but there's a lot of ways to do it. Maybe some remote file include exploit, file uploads, or maybe you just get direct access to the source code on the server itself, and you can access it directly. But bottom line, you've got to get your code onto a server. So everything I'm talking about is post-exploitation. I'm not really talking about exploitation right now. So these are payloads you need. And if you are doing any sort of attack, you need to have your payloads ready. So you need to know what you're going to do when you actually gain access. So you've heard the whole term shell is just the beginning. Well, you need to have that thought. I can go and I can pop a system and say, oh, I got access, but who cares? There's no impact. There's nothing going on. You need to think about what are you going to do with that access. And just by gaining access, do you really have access, or are you going to get caught and burned really fast? So that's where I'm at on this. So it's a post-exploitation and thinking about what kind of payloads are delivered on systems. So we're going to keep talk real quick about a very simple payload. I'm using PHP, which, by the way, is probably the least system I ever face. I just use it for quick examples. So let's go through this quick, simple code. Most web shells are based off of this fundamental, whatever language they're written in. So if you look up here, I'll start right to left reading the code. So I've got some parameter called Q, HTTP GET request, the thing you would see in the URL bar. You'd say Q equals. So this is what's going on. It's going to run the system function, which is going to execute that command, and then echo the results back. Very simple. This is pretty common way a shell is run. So let's see, what does that look like? So honestly, this right here is functional. If you had a PHP app, functional, it's going to do what you want. But there's problems with it, and this is where primarily what I'm trying to talk about. So let's look at a demo of this real fast. Give you some ideas of what this means. So flip over here. Oops. If I can type my password. Okay. So I have this is just a vulnerable web app that I built myself. It's actually based off the OWASP brick framework. So I just picked and choose various vulnerabilities to put something together so I have a lab to play in. That's really all this is. So if you look over here on this shell, let me clear this out. So this is, can you guys actually see that at all? I have no idea if you can see that. If I can do that if you need to. So this is simple shell.php. So somehow I got this uploaded to a system. Don't worry about that. That's the exploitation piece, different topic. But I was able to exploit a system and put my payload on here. So if I visit it, it does nothing. As the source code said, it did no rendering of anything other than what that function was. So if I actually enter a piece of data, such as ipconfig, I get data back. Simple. This is the fundamental piece of how web shells function. It's ugly. So this is an ipconfig of that machine. So obviously the target is a Windows-based target, because I ran ipconfig. It took the information and put it out here. It's ugly. Now the ugliness comes down to because I'm in a web browser and I'm not doing any pretty HTML formatting. And that's a separate piece. But this is where web shells usually are built from this basic function, and then people make them look pretty through a web browser. So they're usable. So, I mean, I can do things, here's a whoami command. I can run PowerShell to do some local user account enumeration, whatever. This is normal Windows commands on your target. Whatever context that user is running under the web server, that's the permissions that you execute from. So that's interesting. So that's the how it functions, but that's not what's important to me today. I can show you, hey, this is a cool tool. Honestly, the tool part of this is, it's just there. It does what it does. The important part to me is, so how do I not be caught while I'm using these things? So let's take a look over here. Let's look at some logs. Okay, I'll zoom in a second on that. But this is where it's important to note. So whenever you're doing any sort of attack, and you're using payloads, you're using tools, my approach is going to be, I'm going against an active, determined defensive group where they're doing their job. A lot of times we face things and we just assume that their defenders are terrible, they've got some tools set up, and they might be bad. But that's the wrong approach, because then you don't really you get to say, hey, you have a port open. And it's like, who cares if you have a port open? What does that mean? What impact is there? And this is where you start to think, when you actually deploy tools, you don't just test if an application has a flaw, but you test, does the application have a flaw? Are there means for people to detect it? They have other logs out there. The entire scope of security is what becomes important. And that's the approach I put, so that one of my core roles is I do adversary and threat emulation. So that's what I want to do. I want to make sure I look like a bad guy who's really trying to come in after you, not just firing up some, back in the day, MSO 8067 and is going and popping some interpreter connection. That's nice and all, but what does that do for you? You want to make sure you have something realistic that real bad guys are using. So when you look at this here, this is what a log looks like. So you can see this is Apache. So it doesn't matter if it's Apache, IS, whatever it is. They're very similar. But you see I have a GET request to this location, simple shell, Q ipconfig. So right there in the log, I am leaving an evidence that I ran a command inside their log. So sometimes that can stand out. When I look at this, I don't think of a person physically looking at all these. These are tools and scripts and things people have looked at to scrape out to give a reason to go do further investigation. And then on the flip side, the error log down here, you see there's some errors. So these errors came because I wasn't handling my PHP code properly. And if you don't enter a parameter, it was expecting a Q parameter that's null, you get an error. So I am, by using this simple shell, which is functional and could more or less do what I need to do as far as issuing remote commands on a system, I have evidence that I don't like. Let's look at the traffic. So now we have, see, what does it look like on disk? What does it look like traffic-wise? I pulled this out of a packet capture and only got the HTTP request and response. All of this I'm doing is all HTTP, so the request-response pairs are what you care about. So when you look at this, you'll see I've got a GET request right here. I see the IP config again. So in the GET request, and you have some headers. Not too big of a deal there. We'll talk about some of that in a minute. And then the response comes back. And if you look at the response, I have the entire, what you would see at your normal Windows command line. So this is what it looks like on the wire. When you start to run a lot of these commands, there's a lot of IDSs, even simple default settings that will trigger this, and you'll be caught. I'm not talking about SSL right now. That's a different topic, and I will hit on that. But right now, we're just assuming everything's clear text across the wire. SSL actually makes it better for the attacker sometimes. So we'll talk about that in a sec. All right. So, like I said, feel free to interrupt with questions or anything if you guys have anything while we go through. So I just did a list, examples. There's just tons and tons of these shells out there. I mean, I have used maybe a dozen or so over the years and then tuned and tweaked these. I've used these things for a long time, various pieces. And that's where the birth of this framework came up that I'm going to show you guys. This is something you see. This is a common console. So web browser based. Where it just has all the clickies where you can click on things for file upload, download, issue commands, maybe some database connections, whatever someone wants to code that particular language and server can support. And so this is a common way. So you got these hundreds of these things out there. There's lots of functionality. Why would I build my own? Well, I spend a lot of times looking at web applications and attacking things. So I need a payload, first of all. So I need it. So I have a need for something. Well, there's some out there. I've got to get this code executed on the box. And I started to work with various ones and building and tuning and customizing them. And I had a collection. I'd pick this one and it had some functionality. So it was getting frustrating. And also a lot of these have known detections because I was taking something out of the box, not really paying attention to what does it do. Whenever you start to do anything from an adversarial side, know your tools. Know your tools, know the protocols it's doing, know what evidence is going on. I have no problem leaving evidence. That's not the issue. The main thing is to know what it is. So when someone says, hey, you left this file, I said, yes, I did leave that file. I did it on purpose because I wanted to make sure that your defending team had chances to see this so they can learn and go from that. One of the things I've learned from testing so much is beating up on the defense and telling them they're bad. I mean, that's going to go on forever, but you've got to help them fix it better. And a lot of times they don't think like an attacker. I actually see that one of the biggest problems we have is to not have the mindset and speak to people that have attack systems, not just theoretically gone or done pen testing, but really gone after and seen things. You'll be surprised what you can learn. On the flip side, talk to defenders to see what they have faced, to see their issues and nuances. And because I wanted to write one. I write a lot of tools. I don't publish a lot of tools, but I write a lot of stuff, and they're just personal challenges, which I'll challenge every single person in here to do. If you have any role in a technical side, you need to be writing your own tools, period. I don't care if it's a simple script that just does something search. You need to do that. It is really, really good to help figure out what's going on. I don't care how terrible the code is. Don't worry about that. My code's terrible too, so it's not a big deal. So where have I gotten caught? This is the whole fundamental of what was important to me to build my tool set. There's a lot of places I've gotten caught, and yes, I'm not ashamed to say I've gotten caught. I learned from that. You're only going to learn from the times you fail and things happen, so that's how you pick this up. You learn from when you actually exercise this and see outside of theoretical pieces. So I just picked a few of these that are key components to being caught in this type of scenario. So default user agent strings. You guys are familiar with the user agent string in a browser and such? It's basically it's just a piece of text that the browser says, here's what I am. Now, so they could say, oh, I'm Internet Explorer, I'm Chrome, or whatever. I'm running on an iPhone, I'm running an Android, running on a Windows box. So it's these types of, it's an identifier. And those are key because wget, curl, Python, anything that speaks HTTP has their own user agents. If you don't handle those, you are giving yourself away in a way that you may not want to show people that you're doing. If I didn't handle, this is a Python-based project, I would have default user agents with Python user agents. Not necessarily how I want to portray myself. I'm guessing you guys don't know what this is, but anyone know what this user agent is? Probably not. This is, because everyone uses Kali, backtrack back in the days and uses Kali Linux, so it's just a hacker tool. If you just fire that up and use it, that's what you're screaming out. You have a signature saying, I am using Kali Linux. Doesn't mean it's a bad thing, but you are browsing someone's system as with a default user agent string on a 64-bit Kali machine. So not necessarily something you want to portray. Maybe you do, maybe you don't. But my point is, it's something you should control. You saw the log I showed you, OS commands and GET request logs, so straight web server logs. You can see your operating system commands. OS commands moving across the wire. I have definitely been caught doing that before, to where you have not necessarily the command, but sometimes the result of the command. Depending on what you're running, maybe something in that result can trigger. So all of that clear text. And then clear text binaries. Web shells are great and they're nice, but they're not a full extensive tool set. Maybe you need to bring something else with you, so you need to move some files across. So moving files across clear text, you might see something such as an MZ header on a executable, on a Windows executable might be triggered. And doing too much too quick. So all of those nice GUI frameworks that are great and they have all this functionality, that's awesome, but it encourages a lot of clickies. And people start treating that as a interface, like Windows Explorer. Hey, let me browse this thing. Every click is an HTTP request. So be aware of what you're doing every time you hit enter to do a command or click. You are talking to your target. So there's opportunities for being caught. So the challenges I found with these existing ones were a lot of them are known bad. So I had to deal with that. That's not always hard. You can rewrite it or change it, obfuscate it some way. But, and a lot of them are written to use the browser, which I did not necessarily like. One, because of the speed of it, and also because they're heavily GET request based, which means GET requests with parameters in the URL are going to be written to a log somewhere. Now, I'm not saying you can't log other stuff. You can't log the post. You definitely can, but I looked at the standard setup, which is very common for people to use. And also, there's so many types. There's 100,000 of these things that people have built over the years that I needed something that I can control and use, that I knew exactly what it was doing. And no obfuscation over SSL. Quick sidebar on SSL. Everyone says we got to do SSL everywhere. And that's great for privacy and data protection. But what does it do for your attacker? It encrypts and potentially blinds your own sensors and your own systems against yourself. Example, I've seen this happen too much. You go on the compliance side. Compliance says you must have end-to-end encryption on your web traffic. So a lot of times, what does that mean? Well, that means from the browser all the way to the server. Cool, so now that's protected, check that compliance box, you're good to go. But what else does that blind you to? All your IDSs, any network sensors, anything you have are blind. So make sure that's not the case. I can't tell you how often I have gone after a site. I'm attacking something, HTTP versus HTTPS. I want to go after the HTTPS site first. I can do a lot more things against that site because it gets into a whole different topic about people using the wrong protections. Encryption is not there to do any protection against bad guys doing stuff. It's to hide your data, which means you can hide it from yourself. So with that, this tool set I wanted to build was protected even if you have just straight HTTP non-SSL sites. So I'm introducing these two tools, SUBSHELL and TinyShell. So what it is they're Python-based command and control clients that remote control code that you put out on your web server. So basically the web shell. It's a common interface so I wanted to have a single common interface that can work with any of the shells I use. And why did I do two versions? I've had SUBSHELL out for quite a while now, and I was going to release it. And honestly, someone challenged me, said, "Hey, why don't you do this better?" And I was like, "Oh, this is annoying." And so I'll show you SUBSHELL. SUBSHELL is a nice, fully functional, kind of traditional shell. It's about I don't know, 190 or so lines of code. You put that on the end system, great. He says, hey, I can do that in one line. It's like, what? And so I took a break and figured this out. I figured it out just a few months ago, and it's really simple. So basically, TinyShell is SUBSHELL with one line of server-side code that you can do in there. It's become an experiment. I'm seeing what limits it has, but so far it's working really, really well. So basically, that's like I said, everyone needs to write code because someone's going to challenge you to do something better, and you just figure something out, and it works out well. So I'm actually testing this to see how well this works in the real world. So when I first started thinking about this, what was important to me? I wanted to minimize my attention. I just don't want anyone to have a reason to look at what I'm doing. I wanted to have a single command and control that supported multiple types, so multiple languages, safe without SSL use. Right now, I'll just admit, it's just base64 encoding. You'd be surprised how much you can get by with just base64 encoding. It's just kind of funny. And all the normal features, OS commands, upload, download, etc. Side note, let's see what time it is. Okay, I'm going good. Hiding in plain sight. This right here is really important to what I've done. So the more I do offensive type of work and I attack, you start off, you learn things, or you see the movies or something, there's always hide your tracks, cover up your tracks, do all this. And that's great. And if you can, that's fine. But think about it realistically. What are you going to do? I'm sitting in a web browser. I'm attacking. Let's say I use a web browser to do an attack on something. Well, I've got to go through, some external boundary connection, maybe some routers. Got to go through firewalls, possibly some proxies. I've got to get onto that web server itself and execute web server code. And there's also the operating system underneath it. So and there's probably other, IDSs in between, all of these sensors that are out there. There's no way, I don't care what you're doing, there's no way you're going to control all of that and clean up your tracks. So what I've learned was, even with good defenders, there's so much information and so much data. So if you can understand and you can blend in, hide in plain sight, basically don't give the defenders a reason to look. Because if you have a decent team defending, they're capturing the data, they may not have a trigger to fire off some alert, and forget about that. That's just crazy. But anyways, if you have some intelligent people that understand how to do data mining on their stuff, once they have a reason, basically all of these things, something looked weird, they can go and peel back the layers and instantly see everything you've done. So that is very common. I see this happen. Obviously we see this because if you look at any of these guys who do instant response and they look at reports of real attacks, they have lots of details that they can pull back because evidence is there. So my goal is to minimize the evidence to not give a person a reason to look. Okay. So how do I do this? In this tool set, I'm using post requests to minimize data in the web logs. There's some improvements in this space I can do, and I'll show you that later. But I also started hiding things in the HTTP header. So instead of using data through a post parameter, I put it in the HTTP header. I'm encoding the traffic. So encoding both what I send and what I receive. So I want to control both sides of that so that I minimize any sort of sensor seeing something strange. And I have a console interface, and maybe this is just my opinion, but I feel like it slows you down, makes you a little bit more deliberate in what you're trying to do. So it's a more serial type access instead of just like blasting away. This is meant to be the web shell, at least the way I intend this to be used, is a long-term command and control backdoor into your network. I'm going to use it. I might use it quite a bit at first, and then it goes quiet. And then I'll move on to other, maybe some client-side tools or something. Maybe you'll start to fire up like a Metasploit or Cobalt Strike Beacon, or maybe use PowerShell Empire, or whatever framework you use to live inside the network to do all the fancy hacker things. And this stays quiet and lives there. I recently did an engagement to where spent about 2 weeks doing some stuff, had a web shell in there, came back about a month later. After it was like, here's what we did, go find it, do some practice, clean up, and get everything going. I came back a month later. They cleaned up all the other stuff. My web shell was still right there, ready to go, because it was sitting there quiet for the whole month. There was no reason for them to look. They had not enough evidence to know that that was important. So these are really good for long-term backdoors. All right, so let's talk about SUBSHELL. I'll go into a quick demo on that. And I know I'm going maybe quick, maybe not. You guys got any questions or anything? My excuse to take a drink of water. All right. Okay, so let's go over here. All right, so SUBSHELL, let's see how, can you guys see? Yeah, I can zoom in if we have to. Let me do the full help. Okay, so this stuff, once you get into it, it's a shell that's not very exciting. It runs commands, uploads and downloads files. But some key features I wanted to show you right here. I can set the user agent if I want to. So I set the target, so actually where did I deploy the shell? What user agent do I want? I've defaulted to this user agent. Nothing's fancy about that. And then also in this case, I have some MySQL connections. So a lot of times when you're on a web server, there might be some database. When I build all my tools, I'm definitely going to say I don't necessarily build them for the masses. I had a need, I built it, and I use it for this. I try to make reusable code and stuff for myself. So I had a need to have database connections, so I added it to this tool set. So like I said, this is post-exploitation. So a lot of this stuff you would have had through other means. You would have already compromised, exploited, gained some intelligence, and then you can use that to support this backdoor. All right. For cheating, I'm going to use my copy and pastes here. Because, all right. So I connect to SUBSHELL. So this is what the framework looks like. It comes up, it shows you where it connected to, and it gives you a current configuration. Is that cut off a little bit? Yeah. Maybe that's a little bit better to see. I don't know. So the current configuration. So you see a user agent. I've got this HTTP timeout. I'll actually explain that a little bit more later. And it shows you the current directory. Basically, the current directory is where the directory of that shell lives on disk. And then I have some database connection information. So from here, I can do the normal things like do a dir, IP configs. Nothing fancy, just normal Windows commands. It issues a command, waits for the response, and prints it to the screen. So just like the simple shell that I showed you before, which is a big blob kind of there, this is made pretty on a screen to kind of emulate a terminal. Nothing too big here. I can upload files. I actually already uploaded it. Run this. I've got a help menu here. So if you want to know what's going on, all the features and capabilities you have, normal console type things, nothing quite fancy here. So what I like about this is when you get into, so what does this look like on disk? What's the traffic? Where's that? So just like the simple shell, this is a fancier version of that. It just gives you the ability to run commands. So nothing special there yet. So what I've done is, let's take a look at the logs. So I forgot that highlighted there. So this is a little cutout of an Apache log here. So you see this is what it looks like. You see a post request to subshell.php. Most likely you would not name it subshell.php, but you'd name it to blend into your environment. So now what I have is just one post request, nothing crazy. I'm probably going to start modifying that because sometimes a lot of post requests might look weird. But I'll show you how I'm handling that and probably fix that in the tiny shell version. And right now I've written at least hopefully decent code so that I get no Apache errors. So nothing getting written to the error logs. So it looks pretty clean from a log perspective. So nothing really to trigger anyone to go look yet. And from a traffic side, so when you first connect, it basically when you see this prompt right here. Well, it doesn't know where it lives. It's got to figure it out. So it does when you connect, it does an initial command. Hey, where am I at? And that's the first thing. And then it shows you the status. So here's what it looks like. You can see I'm doing a post request right here. So not a big deal. You see some headers. There's my custom user agent that I was using. And then you see this line right here. And this is what's important to me right there. API key, some blah of stuff. That right there is just right now my encoding, my encryption, whatever you want to call it. My obfuscation is just base64 encoding. That is the PWD command just encoded. That's all we got right here. So we're just doing a base64 encoding of that. And that's enough. And I say that, I've used this a lot lately, and this has been working well. I have not been caught. I've been caught other things. Typically, once you start getting on a system and you do other stuff and move and laterally move and do stuff. But this communication has worked well to bypass stuff. In the future, we may change that, but so far, that's what it is. So basically, that post parameter gets there, and all you see on the back side, you see your normal HTTP response headers, and then you see a big blob right here. So just a big blob. That is basically the response that comes back. So you do a dir command. It's just a bigger command. Not a big deal. This would be a dir. This is base64 encoding of dir, the current path, just like you do it at Windows command line, and then you'd get a big blob. That big blob is basically, if I do this, that's all of that data in green right there. That's it. Simple. When you look at it like this we're doing now, it's like, oh, that looks weird. Maybe seeing big blobs. But if you go analyze traffic and start seeing things, you're not really doing it as a person. I'm not saying that doesn't happen. Yes, people get lucky, and they're just looking and digging through traffic, but not normally. You want to try to evade normal kind of protections. And at the same time, the more profiling you do, the more understanding you have of the network, you can tune and tweak these. These frameworks, and I say with this with any tool you use, fix it. Fix it for your environment. You're going to always need to tune and shape stuff to work for what you have. So that's basically how SUBSHELL works. I got a little bit more time. I'll show you just a quick piece how the database stuff works. So in this case, let me do this, config. As you can see, when I started off, I set some creds and passwords. Like I said, this is post-exploitation, so I'd have already gained that. Actually, I can pull this out of the files that are on here, because in this case, this bad web app I have has clear text creds to the database stored in the source. So I gained access to those, and so now I have creds. So whenever I issue a MySQL command, so in this case, you just do MySQL and do like show databases, and you see a list of the databases that are on this box. No big deal, So from here, it's just normal MySQL pieces. So in this case, I have to set a database. Let's just set the MySQL database. Or actually, I'll just do this one. We'll just do the, where is it at? Bricks database. That's the vulnerable web apps database itself. I can do a MySQL. Show tables. You see all the tables out there. And this is the normal MySQL. This is very simple SQL I'm doing now. You can add and do a lot more details, but a lot of times you're just trying to pull out data. Select asterisk from PIII, if I can type. And you get a bunch of stuff. So, it's normal. So I was just using my web shell to connect to a database. The reason I wanted to go through that, not to show you that it can connect to databases, because that's not very exciting to connect to a database, but the feature that I have the result is truncated, review log for full details. So this is what I wanted to show you. So over here I have in the /logs directory of SUBSHELL, I log everything I do. So if I cat out my log, you'll see everything I've been working on. Let me just actually go to the go up to the top. You'll see all of the things I was doing when I was CDing, all the results that I was working on in this thing. But for the databases particularly, this right here is everything I do. So if you notice, the table that was on this screen here, kind of cut, not necessarily the best. That's just a rendered table to my console. So I save that output, but what I also do with your databases, I save all of the records as a JSON string. So you have everything right there that you can extract. So if you need to actually do something with that information, you have the JSON data right there that you can manipulate and pull information out if you want. So that's really the only reason I wanted to show you how that works. So I just store that in a log, and I put a little note there to help you remember, oh yeah, the details are in there, which includes the JSON string. So that's basically how SUBSHELL functions. Let's see if I made some notes to make sure I covered everything I was going to show you guys. Yeah, that's so, normal commands, file upload, download, do some MySQL database stuff. Not anything crazy. The big thing for me was, versus other ones, was I wanted to be hidden as best I can, especially over HTTP environments. All right. So, you guys got any questions? Yep.
So, it seems like this is really cool, by the way. One of the things that you're doing a lot is trying to obfuscate the logs and detections, right, on their system. Presumably they may have some processes looking for evidence of this stuff happening.
Right.
And one thing that came to my mind is you also have this little piece of code, either ASP or PHP or whatever, that you're dropping on the server when you pwn it. That file, to me, seems like it would kind of have a signature, right? Like,
yes, it can. Definitely, yeah. Yeah, your file will have a signature.
Is that... Do you run risk of detection there if they have some monitoring file system or something?
So good protection against these things, which maybe you guys can be the first to show me. I don't know if I've ever had anyone do file integrity detection on a web server or on all of them. A lot of them, they say, oh, these are critical, important ones. And this one over here is just a blah. It's just some HR thing, not a big deal. Oh, by the way, this one has to be running some old outdated software as root on a box. And it has direct connections into your Active Directory network. And these things happen. People set up that not important box over there, and I can't tell you how many times I've used that as a pivot point to go in and take over entire networks. People just think it's not important. It is. If it touches and if it's a path into your network, it is important. But with what you're saying is some file integrity monitors to know that changes happen to your website. Your web's data, any files you have out there should never change without your control. So if you've got good control processes, depending on what type of site it is, if it's something you roll out through, maybe some kind of source code review process and you push it through, that's a good way to do it. Or just...
Is there any way for you to obfuscate that file itself?
Yes, you can. So there's all kinds of crazy obfuscators. Now the file, I'll have subshell.php or help.php or whatever the name, I'll have to have a name of something there. But the contents you can obfuscate. You can change it so if you don't want to have a common signature. A long time ago, I wrote a botnet that I was using, and every time you generate a new binary, it would have a new signature, just because I had random stuff go in there, so that you'd never, just for silly MD5 detections, it would just change every time. So it's very simple things to bypass. So it means understanding what security people use and where they trust, so those signature-based things. A lot of the detection that I'm trying to focus on is anomaly and understanding your network and looking for weird patterns and traffic to isolate abnormal behavior. Because once you find that, then you can see who's doing weird stuff and dig into what they're working on.
Thanks.
All right, so let's talk about TinyShell. So it looks almost the same. I just want to talk about a few key differences. The reason, like I said, I built this one was the other one was fine, and instead of branching it out and changing it, I said, let me just start a whole new project. It's basically the underneath is more or less the same, but this one I was challenged to do some one-liner payloads. And the techniques that I was shown were really cool, but they were limited. They were very focused and limited. I said, well, how do I make this not limited and go stuff? So I just did some research, actually found some Chinese malware that was doing more or less what I wanted to do. And I looked at that and I said, oh, this is cool. I really did not like the way it was implemented, but some of the fundamentals helped me with some security programming issues that I was having, like some challenges. I didn't know where the next step to go. So even someone like, I've been doing this for a long time, I don't always know the next step. So I did some research, got help, and that just kickstarted this whole thing. So what I'll say, one thing to compare, which I did not show you this before. So this is the SUBSHELL code. So this is everything you get put out there. You see it's 191 with some spaces and stuff. So that's actually what you have to dump. You have to dump that whole thing as a standalone file out there on the remote system. Okay? So that's how SUBSHELL is going to work. Now, TinyShell, like different. So it's all of it. If you see, if I do a single line on the server, obviously that's going to be kind of dumb. It doesn't have a lot of knowledge of what's going on. So all of the code and processing has to happen on the client side. And the client has to tell the server all this stuff to do. It just does its task and then comes back. So with that, there's some more things you need to tell the client how to operate. So I've got to choose the language. Right now I'm supporting ASPX and PHP are the only two I've gotten written. There's some other challenges in other languages. So we'll see if I can add to that. So anyways, it gives you now instead of having 100 shells to choose from, I've got 2 to deal with. I've got this traffic mode. So this is what I like better. It's the beginning of my traffic shaping on this. So you can create profiles to look like different things. Right now I support clear text, base64 encoded post requests, and base64 encoded header. So those are have started this. And so far, the base64 encoded header is working really, really well. Clear text you probably wouldn't use. I used it more for debugging and troubleshooting. Of course, you get your user agent, and then this piece here, this password here. So password is the unique string, so either the post parameter or the unique header that you're actually going to use to indicate that you're trying to talk to it. So it's the password to actually have communications. All right. So let's fire this guy up. So in this case, let me show you this. So right here, what I'm doing, the string I had was, if you guys can read this, I connect to my end system. If you notice this time, I'm going to bricks index.php. So I'm not going to like SUBSHELL buried off somewhere. I'm actually going to the main website's index.php page. So I'm hiding even more. I'm actually on one of their pages. I've got this password. I call it the csurf token. I'm doing a base64 encoded post mode and over PHP. So that's the context I'm in. And actually, I guess I could have showed you here. So here's all the parameters that we saw with that. Because I'm hidden in the index.php page, and I'll show you what the source looks like in a minute. And I can, with this, you can actually deploy it to multiple places. So if I'm working on index, then I can change to help.php or wherever I need to change. But what's interesting with that, when I did a response back, I get the entire page. So whatever the index page looks like, that's part of the response. I don't care about that. So I've used this header and footer basically as markers within the response, so anything in between that is what I wanted. So everyone else can use it as normal. It looks fine. When I use it, I get a little bit extra stuff. So it looks more or less normal, especially if you blend it into a page that has dynamic content, maybe a search page or something like that. Okay, and you see my directory is actually in a different location because I'm in a different place. But the normal things here, dir, IP configs, whatever you want to do, this is the same. From this point, it's the same. What's interesting about this now is, let's look at the tiny shell log. So log, pretty much identical to what SUBSHELL looked like. It's a post request, and that's all you see. I'm probably going to change that to have post or get, and I'll show you why in a minute, because when you're in header mode, you get more options. So let's look at what the traffic on the network looks like. So this is where your IDSs and all your defenses are going to see. They're going to see a post request to index.php. Probably not too weird looking so far. You get normal header type things. I've controlled my user agent. Everything else is pretty normal. Then I'm posting the csurf token. So not too crazy, not any different than what I had with SUBSHELL. So if that can be detected, then fine. But if you also notice this time, where I had API key, had the small one, this is pretty big right here. You get this big old blob. So let me show you what's inside this blob. All right. For decode, you're seeing my secret ingredients for my awesome encoding. So there you go. That's actually what I'm sending. It's that big blob, and it gets evaluated on the other side and decoded, de-encrypted if you want. But so far, base64 encoding is awesome. It works great. And it's not weird because there's lots of stuff that move across HTTP base64 encoded because it's friendly to move weird types of data. It's a friendly way to do it. It does add overhead, but it works. So basically what you're seeing is normally what I was doing where I put all the server-side code over there on the server. Now I take chunks. I take a function and I shove that whole function over there, let it evaluate. And so this thing basically says the server's dumb and all it's going to do is execute. So the client has to say, I want you to do something, get some result, and send that back to me in this format. So that's what the client does. So at the cost of a little bit more network traffic to push this over, I get to hide better inside the network and have just a single line of code. I'll show you what that looks like in a sec. So back to this network traffic. So here's the traffic. So I do a post request. This is what I'm sending. And when I get down here, you see this is the normal stuff you see with the what you'd see in the web page. This is what the index page looks like, which is actually, I think I showed you guys that right at the beginning. So that is this page right here. So that's where my PHP code, my shell is hidden on this. So all of this HTML that's coming back is that. I truncated it just so you can see, and then I get this right here. So this is the extra stuff that I added. I have my header and footer. Now you can adjust those header and footer to what you want. You can adjust them as you're working. So if you wanted to change your profile as you're operating, you can. The one thing you have to be careful of, and that's why it looks like this right now, you can do HTML tags and hidden, but you are still posting data, so there can be protections. So such as a lot of even default settings say, hey, this looks like malicious traffic. If you've seen that on a Windows box, like if you try to post maybe some brackets or various things, it gets detected or gets blocked. So you still have to deal with that. So that's why right now my example is just really simple, because you need to understand your environment, test for that condition to make sure that those parameters can actually be sent. So I send those. Everything in the middle is what becomes my response, and I move forward. And then the other mode, this is my preferred mode right now that I'm really doing a lot of testing on. Like I said, I've used these shells for a long time. The tiny shell is fairly new, so I'm starting to see how well I like using it. But so far, it's working well. So this time, you see I do a post request, nothing, no parameters. I'm not saying any parameters. And I just have something called psession. So I got this big, long session token, which is not a session token. It is my command that I'm going to issue to the remote system. So I can hide in the header. A little bit cleaner, and in this case, I can actually change over to a GET request. So say the index page never gets a post request, I can switch this over to a GET request and always just do GET requests. So it blends exactly like everything else. You just have an extra header that no one cares about, no one knows anything about that header, and hopefully it just blends in. So the response is identical. So request is different. Limitations, obviously it's a header. It's not meant to carry tons of data. So I have about 8K is the most comfortable you can do. So if you try to upload files and such, you're going to have limits. On that note, the way I'm doing file uploading, I mentioned obfuscating of that. Instead of, normally with web, you can just hit download and it does something. There's a lot of back-end features to make downloading of data easy and efficient. I don't use any of that. I read the file that you say upload. I read the file, read all the bytes, convert that to base64, shove that across, and then undo that on the other side. The reason is I want it to be obfuscated on the wire over clear text detection. So, for example, say I have a binary I want to move. And then, normally .mz header will be detected from a Windows binary. So I base64 encode that, shove that across, and then decode and write it out. It works really, really well to bypass lots of security devices. So I use that. With that though, you have limitations because you have overhead on your files whenever you do that. In this case, I have 8K for headers. But my intention for this tool is to be a long-term backdoor to enable you to do other things. So that's what the traffic looks like. And this is the shell. That's all you're doing. It's just silly, stupid how easy it is. But this is actually two shells. So I can have different modes. I can have a post mode or a header mode. So that's all I'm putting on there. And all the work is done on the client. So I can just inject that. So let me show you what that looks like over here on my Windows target that I used. So, I got it pulled up right here. So here's the index page. So that's the normal index page. And then you just see, whoa, it's going too fast. Right here, I just injected those two shells. That's it. So I can talk to it. So it looks normal, except for I added change. So if you're actually on a system and you're attacking this, if someone does some kind of maybe some date timestamp modification, you can just change date timestamp back to what it was to try to avoid detection on that. Of course, the hash will be different, but it's easier to hide when you're only doing one line of code change instead of a whole new page. And you can inject this into a lot of pages so that instead of always going to index over and over, you can bounce around. So all right, that's more or less Tiny Shell. I got a couple more minutes. I'll show you one last piece. Basically, my intent, how I use this, what I'm going to do with it. So with Tiny Shell, like I said, these are long-term things. Right now, it's sitting at this prompt. It's not doing anything. There's no communication going on. Only when I do a command, HTTP request, HTTP response, quiet. So that's how this works. So that's good because now I have a way to stay in. Maybe let me kick something else off. Maybe I'm going to use PowerShell Empire or Meterpreter or anything. So in this case, I want to show you, hey, let's kick off I'll use Cobalt Strike, the beacon on Cobalt Strike. And very simple thing here. Let's go back to my cheat page. So this right here, if you're familiar with this kind of code, this is PowerShell code to do a download and execute. That's all it's going to do. It's going to say, hey, go download whatever you find on this page, just run it. So I'm going to use this as a method to kick this thing off. And there's another reason why I'm showing it as well. So it's running, and we're waiting, and we're waiting. It's not doing anything, it looks like, but hold on a sec. If you remember, I had a timeout of 10 seconds. So, oh crap, I got an error. This is important when I say know your tools and know everything that's going on. So what just happened was I ran something, in this case, PowerShell.exe. It never returned. So I got an HTTP timeout, which is what I told this tool to do. I said, hey, wait for 10 seconds. If you hear nothing, forget it. It's done. So what happened was I ran a binary. This is no different if I ran calc or something. And if I just pull up Task Manager, I'll show you. Should have PowerShell running. Oh, I love it. Man. Isn't that awesome? So, all the times it worked. So, it should be running. It's got the right IP address. Anyways, I don't have the reason why it did not work, but that's fine. It's PowerShell running now. I don't know what happened. You know what? That's what happens in life too when you're actually doing these attacks. Everyone, side tangent, everyone wants all this stuff to run perfect, and hackers did this thing. It's not a science. It's just perfect and exact. There's a lot of art to it. So when you start to have those people to say, hey, just execute. Why didn't that work? You know, this is not an art. You're doing things that were not intended to be done. I'll flip it and say, well, why doesn't your system that you wrote to do these things work right? It's the exact same thing. Computers are hard. So I got a timeout, but PowerShell is running. So this would be no different than if I ran calc. It waits. I got calc pop up. I close it real fast, and it came back and returned before the error. So that's all it is. So I just be aware of what's going on, what those timeouts mean. So the reason I ran that PowerShell command was really, let's see if it worked, and it did not work. So I love tests and doing live demos. It does work, and I have no shame when things fail because I fail all the time, and that's the only way you can figure out how to make things work. So I'm not sure why, but I should have got a callback. So in real life, you're going down to, oh, wow, my whole setup worked. I got to figure this out. But my intent was to get a PowerShell command to run to get a Cobalt Strike beacon going. I don't know why it didn't work. I'm not going to try to figure it out now. We'll probably figure it out in 5 minutes after we're done. So that's how this would work. And I would let this thing go quiet. I would move over to another piece. Like I said, this could be a Metasploit framework, Metasploit interpreter, PowerShell Empire, Puppy, homegrown, whatever you want to use for your long-term command and control and such. And this thing would go quiet. And that's pretty much it. You guys got any questions, comments, whatever? It's quiet. And it doesn't work. It's because it failed, isn't it? That's why. Yes, sir. Yes, I've thought about all kinds of that stuff. So, yeah, he's asking about inside like TinyShell to have the password to be encoded or XOR'd or something. Yes, so the whole thing, I guess I can flip back over to, I had my other slide. There we go. So, TinyShell, there we go. Future improvements. Didn't include that, but yeah, so better logging. Encryption, which would fall under that category. So actually real encryption instead of basic64 encoding. XOR, even XOR stuff is good to obfuscate things. Right now, if you noticed, I didn't do anything authenticated. The entire backend framework is written in the Python requests module. So adding authentication is not too hard. Sometimes it can be. So logging onto a website is harder than you think when you do it programmatically. So sometimes it's hard to code that in to your environment. Most of the time, I just steal session tokens and just put that in there, and that's my authentication. But I could add authentication. This doesn't have it in there. It's easy to add. You just need to know what your target is and add that special authentication into to your shell. And then a blend of the gets and posts to have variety and to blend in a little bit better. And then adds Linux. So I don't know if I mentioned at the beginning. This whole thing I built with the target of a Windows environment. Mainly because that's what I needed, and that's what I still need more than Linux side. So I've built this to be Windows focused, but it's easy to add this from a Linux side. So, and I guess I can be official. There we go. There, I'm at the end. Any questions? Any more comments? Anything? All right, well, good. Thank you, guys.